Alright, so we're going to look at an arithmetic series which deals with adding together the terms in an arithmetic sequence. So we have a couple formulas. The first one here is dealing with the sum of a finite number of terms. So maybe you want to add the first 20 terms in a certain sequence. So this formula here is n divided by 2. N is the number of terms you wish to add up. We know that u sub 1 is our first term, and remember that u sub n represents the last term. So make sure you look in your formula packet and you'll see that the third formula given to you is this one right here, alright, which is for an arithmetic series. Now, you'll see another formula listed right next to it, okay? Let me show you real quick where this other formula comes from. So u sub n, we know, is the same as u sub 1 plus n minus 1 times d, right? That's the general formula for an arithmetic sequence. It's given to you. Well, if we clean this up a little bit, you can see that these two together would give us 2 u sub 1's. So that's where the other formula comes from that you see in your formula sheet. So you'd have 2 times u sub 1 plus n minus 1 times d. Now, how do you know when to use which one? Well, with the first one here, if you know the last term that you are adding on in your sequence, then you can use that first one. Notice how with this second one, though, you don't need to know the last term. All you need to know is n. You need to know your first term, and you need to know a common difference. Okay? So we want to use this one if you don't know the last term. Okay? So make note that you're given two formulas here. So let's look at an example. Okay, so in this example we're looking to find the sum of the first 15 terms, and we're given the series 29 plus 21 plus 13 plus ... Notice we don't know what the 15th and final term is that we are adding on. So, well, what do we know? Well, we know the first term is 29. We know the n value is 15, right? We're trying to find the sum of the first 15 terms. And we can gather that the common difference is -8 since it's going down by 8. So, from up above, we are going to use this second formula because we don't know the last term. Now, could we find it? Yeah. But since we know these three, it's just easier to use the second formula. So, S sub 15 means we're trying to find the sum of the first 15 terms. So, n is 15, so 15 divided by 2. Then you have 2 times the first term. I said the first term is 29 plus, again, I'm just plugging in straight to that formula. Not much to it. 15 take away 1, and then our common difference is -8. And then you just need to very carefully go through this and simplify it. And if you do that, the sum of your first 15 terms would be -405. Don't take my word for it. Simplify it, all right, and make sure you're getting that. Okay, so make sure you're doing, this would be 14 times -8, and then you're adding on 2 times 29. Okay, get all of that, and then when you're all done, multiply by 15 over 2. Okay? Okay, in our next example here, we're looking to find the sum, and we have another series. We can see that it's arithmetic, since it's going up by a common difference. It appears that the common difference is positive 1.5, right? And then notice we have our last term of 50, okay? That represents our last term, u sub n. Well, what's not clear here is, well, how many terms are we adding up, okay? We know the first term is 14, the common difference is d, but as far as picking out which sum formula to use, well, both sum formulas require us to know what n is. So, write yourself a note that we must find n first. Okay? So to find n first, we have to use our u sub n general formula. Okay, again, make sure you select the right one. This is not geometric, it's arithmetic. So our last term is 50. So we can put a 50 in for u sub n. Our first term is 14, and then our common difference is 1.5. So if we solve for n, that's going to tell us how many total terms that we would have, all right, where 50 is the last term. Okay, so if we solve this simple equation, you want to subtract over 14 first, then divide by 1.5, and then add 1. If you do that, you're going to get n equals 25. Okay, so this is really u sub 25. Okay, the 50th term, or I'm sorry, the 25th term is 50. Okay, so we are trying to find s sub 25. So we now know there's 25 terms that we need to add together. So since we know our last term, let's use this formula here. All right, the one that has the last term in it. So we're going to have 25 over 2. Our first term is 14. Our last term is 50. So anytime you know the last term, you want to use this shorter of the two formulas. There's just less to plug in. And if you clean that up, you're going to get exactly 800. Okay, so the sum of all those terms would be 800. Alright, last example. We're looking to write an expression for s sub n, which represents the sum of the first n terms. And we're given the series 64 plus 60 plus 56 plus dot dot dot. And once we've done that, we want to hence. Now hence is an important word that IB uses a lot. That means we're going to use our previous result somehow. So hence, we want to then find n for which the sum is equal to 0. So we're going to take our sum expression, set it equal to 0, and solve. So let's write down what we know. We know the first term is 64, and we can see it's going down by 4, so the common difference is negative 4. Okay? So recall that since this is arithmetic, recall that we have a couple formulas. We don't know the last term here, and so we're forced to use this other formula. Right. Alright, so let's plug in as much as we know. So we have s sub n is equal to, now keep in mind, there's going to be an n in this, right? We're coming up with an expression for s sub n, so it's going to be in terms of n. So we have 2 times 64 plus n minus 1 times our common difference of negative 4. So let's continue to clean this up here. Alright, we're going to have 128. If I distribute my negative 4, I have a minus 4n plus a 4. From there, I'm going to have 132 minus a 4n. Okay, so this right here is an expression for s sub n. And if we took it a step further, if we were to distribute that n over 2 to those terms, we could turn this into 66n minus 2n squared. Okay, so either one of these expressions is acceptable. All right, either the one in factored form or the one in simplified form. So from there, remember it says hence we want to find n for which the sum is equal to 0. So we're going to take either one of these and we're going to set it equal to 0 and we're going to solve. Now, hopefully you would agree with me, since we're going to be setting this equal to 0, it'd make more sense to use the factored form of our s sub n equation. If it's in factored form already, we know we can just set each factor equal to 0 and solve. Well, in our first part here, 0 equals n over 2, put that over 1 and cross multiply, you get n equals 0, right? However, we can't have 0 terms, right? We can see that right here we already have 3 terms. So this one would not make sense, okay, for the sum to equal 0. We're going to have a decent number of terms. If you look at this, all right, it's going down, so eventually we're going to have to get well into negative territory, all right, for the sum to balance out and be 0. So this one we are going to reject. Okay? Over here on this side, we're going to set that factor equal to 0 and solve, and we're going to get a much more reasonable answer. So n equals 33 would be the n value that would give us a sum of 0. So in other words, we would need to add together 33 terms in order for that sum to equal 0. Okay? And again, you could have gotten it using this other equation, all right, but that would have involved a little more work. Okay? But either way, you get 33. Goodbye.